Okay, I'm hoping this one is a little bit shorter than last time, because last time was a little bit longer than 15 minutes. So we're going to review a little bit, and then we're going to talk about canceling inverses. As promised, we're going to spend a little more time on what we did last time. All right, so we talked about the we talked about the range of sine inverse and cosine inverse and tangent inverse last time, right here, okay? So we're going to add on the fact that the range of sine inverse is the same as the domain of sine, for example. And then we know the values of sine fall between -1 and 1 from the unit circle, right? Because the longest anything can be is 1 unit. So that's the range of sine, which is the same as the domain of sine inverse. I'll show you why this is going to be important in a second. So go ahead and copy those down. This is something you have to have memorized. So please, please, please copy this down. All right, if the value falls in these intervals, we can cancel a function with its inverse. So if you notice A and B, they're both cosine. One is a cosine and the cosine inverse, and then the next one is cosine inverse and cosine. I can possibly cancel and be done in about 20 seconds, okay? Now, when we have a problem like D, where it's not the same function, it's a tangent and then a cotangent, we can't do that. So with regard to canceling, it has to be the same function. So what I want to look at is, I'm going to actually highlight, does this fall in the domain of cosine inverse? Right here. Oh gosh. So this is an input for cosine inverse, right? It's something I'm taking cosine inverse of. So it is a domain value. And does 1/2 fall between -1 and +1? Yeah, it does. If the answer is yes, I can cross those out, and the answer is just 1/2. Okay? So now on this one, I want to ask myself, does this fall in the domain of cosine? So it's an input value for cosine. Does it fall in the domain of cosine? Where do I see domain of? Oh, I wrote that wrong. Darn it, I hope you guys caught that. This should say cosine right here. I'm like, why does that say? Yeah, okay, I didn't mess that up. All right, so anything else? So this is the domain of cosine. Is 3 pi over 2 between 0 and pi? Well, no, it's not. 3 over 2 is bigger than 1, okay? So on this one, we can't cancel out, and we just need to go and do what we've learned in previous sections. So first thing I'm going to do is find cosine of 3 pi over 2. So if you think better in degrees, you multiply, that's 3 90s, so that's 270. 270, 3 90s, yeah. 270 is there. So I have this quadrantal angle with the ordered pair over 0 down 1. Cosine is the x over r. R is always 1 when we have these specific special right triangle angles. So cosine is equal to -1. Cosine of 3 pi over 2. Now this is asking me to take cosine inverse of that thing. So take cosine inverse of that thing. So now the question is, so we got to go through those questions that we had before. Where does cosine inverse live? I need a new picture. Cosine inverse lives in 1 and 2. So I get rid of 3 and 4. Where's cosine negative? In quadrant 2. So then I need to go this way to get my -1. Remember, this is an x over r. What is that? -1 comma 0. So then I need to figure out the angle. This is where this right here comes into play especially. So if I'm taking a cosine inverse, the answer is an angle. So this angle is 180 degrees, which is pi radians. Whew. So this is really putting together the last chapter with what we did in the last lesson. All right, secant. Oh, nobody likes secant and cosecant. Poor secant and cosecant. So I need to think about secant is the reciprocal of cosine. So it's r over x. So I actually want to think of this in terms of a cosine instead of secant because I hate secant. So I'm going to switch it into an x over r. Remember, this right here is the r over x. So if I'm going to take a cosine inverse, I'm going to flip that fraction because this right here is the x over r. And now this is exactly the same as yesterday. Where does cosine inverse live? Hopefully you said quadrants 1 and 2. Where is cosine inverse negative? Hopefully you said quadrants 2 and 3. So we're stuck in the second quadrant. Cosine is the x value. Okay, so I'm going to show you something different than what I did last time. Last time I said, okay, I know this top angle because across from 1/2 is 30. This time I'm going to go, well, I know that because I know my special right triangles, so I know that. Now remember, the reference angle is 60, but the angle itself is the rotation from the positive x-axis to the terminal side. So I need to go 180 minus 60, 120. That's 2 60s in radians. Okay? All right, let's do another. 2 pi over 3. So let me see how I color-coded this before. Okay. Cotangent of 2 pi over 3, I'm going to focus on first. What is that? That's 2 60s, so that's 120, just like we had just said a minute ago. So I need to draw a picture for 120. I already have one, but let's just draw a fresh one over here. The reference angle is 60. So I'm going to label my sides. That's a negative. And then cotangent is x over y. It's the reciprocal of tangent. So that's going to be negative 1/2 over rad 3 over 2. And then just like we did towards the end of yesterday, I want to say, we multiply by the reciprocal. And then we rationalize the denominator. So we get that. Now remember, that's just the cotangent value. So cotangent of 2 pi over 3 is equal to negative rad 3 over 3. And they want, hold on, let me see how I color-coded that. Okay, they want us to take the tangent inverse of that. So then now I need to think, okay, I'm not going to overthink this. I'm going to go back. I know that it came from this. This right here came from that. But now tangent is y over x. So that means the y is negative 1/2 and the x is rad 3 over 2. Well, I just need to be careful though, because the options, let me show you the options for this. It could either be this or this to get that negative rad 3 over 3. So let's go through and ask ourselves the questions. Which quadrants does tangent inverse live in? 1 and 4. Where is tangent negative? So again, we talked about this last time. Y over x is going to be negative when both y and x are... Oh, no, we didn't talk about this last time. It was a positive last time. So y over x is going to be negative when the x is positive and the y is negative, or vice versa. So that's going to happen in quadrants 2 and 4, which means I'm going to eliminate 1 and 3. So now I know these are my potential y values, and these are my potential x values. So I've got 1/2 going down, so that's got to be the negative. And then I can confirm that the x is actually positive. Across from 1/2 is 30. And like I've said several times in the sine problems, for sine inverse and tangent inverse in the fourth quadrant, we rotate clockwise for a negative angle. So the answer to this problem is negative 30, which is negative pi over 6. And the crows agree. All right. I think this is the last two. Yes. Okay. Now, notice. Is that a color I haven't used? I think so. These guys match up. Oh, I didn't want to do that. Hold on. No, let's do that. Those match up. So we can look here and be like, okay, is this in the domain of tangent? That negative pi over 4 is an input for tangent. So let's go back up. the domain of tangent is this, is negative pi over 4 in that interval. Yes, it is. So, lo and behold, I can just cross these off and end up with negative pi over 4 as my answer. So you see how much easier that is if you memorize these? Otherwise, you got to go through all this work that we did in D. Now, these ones don't match, so we can't do the crossing off thing. So we're just going to do one more time. We're going to find cosine inverse of negative rad 2 over 2 first. So we're going to ask ourselves, which quadrants does cosine inverse live in? And then where is cosine negative? Cosine is negative to the left. Oops, I don't want to cross that one off. I want to cross off the ones that aren't negative. And then I know the cosine is the x. Oh, should be doing this in, if I'm really going to color code. Cosine is the x value. Ooh, we haven't done a rad 2 over 2 in a while. So I know that across from rad 2 over 2 is 45. It's a 45, 45, 90. So the reference angle is 45, but just like I said a minute ago, the angle that I want is the angle that starts on the positive x-axis and ends on the terminal side. So that's going to be 180 minus 45, which is 135. Oops, which is 3 pi over 4. But remember, that's not all they wanted us to find. So cosine inverse of negative rad 2 over 2 is 3 pi over 4. But the question is asking us to find tangent of that. So I want to find tangent of 3 pi over 4. Tangent is y over x. So I need to label the y. So this is rad, oh my goodness. This is rad 2 over 2 divided by negative rad 2 over 2. So the answer is negative 1.